Hey y'all, I'm in Paris. Ah! Okay, seriously, I have a lot of things to tell you. Quit messing around, everybody. It's time to talk about physics. Make sure that before you continue watching this video, you have in front of you your notebook and a writing utensil. Seriously. Okay, so the first thing I want to talk about is conductors and insulators. So just going to go through this pretty quickly, but basically a conductor is any material that permits the free flow of electrons from particle to particle. So an object that's made up of a conducting material is going to allow charge to be readily transferred across its entire surface. So if we have a conductor, right, an object that is made of a conducting material, and a charge is transferred to that object, then this charge is going to be rapidly distributed across the entire surface of that object. And a charged conductor can actually transfer charge to another object through contact. And the transfer of charge between objects is maximized when we have both objects, when we have two objects that are conductors. And then the best examples of conductors are going to be metals like silver, copper, aluminum. An insulator, on the other hand, is a material that impedes the flow of electrons from atom to atom and molecule to molecule. So, unlike a conductor, when you transfer charge to an insulator at like a specific spot, that excess charge is going to all remain localized at that initial location. So it's not going to spread out across the surface of the object. It's going to stay in that one spot. So with an insulator, we do not see charge spread evenly across the surface. And an example of an insulator would be something like rubber or glass or wood. And then oftentimes you'll see like conductors and insulators paired together. So like the outside casing of a wiring, for example, just so that charge is not transferred outside of the conducting material. Okay, so next we're going to think about how charge is actually distributed or transferred between objects. So the clarifying point that I want to make is that the distribution of charge is purely the result of electron movement. So protons don't actually transfer. Objects are only positively charged when they lose electrons. So it's only electrons that are transferred, only electrons that are distributed. So now let's apply that to a specific scenario. Let's say that we have this block with positive charge Q1, and then we have this cylinder with a negative charge of Q2. So what's going to happen when these two objects come into contact? So we know, right, that only electrons are going to be transferred, right? Only electrons are distributed. So electrons are going to move from the cylinder to the cube because we know that positive and negative, right? Those are opposite charges, so we're going to attract. But only the electrons can move, so we're going to see that's what happens is electrons travel from the cylinder to the block. The next thing we're going to talk about is Ohm's law, and this is just a brief introduction, but today we're going to really start thinking about circuits. So mathematically speaking, Ohm's law is just V equals IR. V, voltage, is equal to I, current, times R, resistance. Sometimes Ohm's law is also written as I equals V over R. So we would say that the current of a circuit is directly related to, directly proportional to the voltage and inversely proportional to the resistance. Okay. So let's talk about voltage first. Voltage is what we call electric potential, or think about it as the potential energy in each unit of charge. And for voltage, we use the units, as you might have guessed, volts. Current, which we symbolize with capital I, is a measure of essentially just a measure of charge over time. So how much charge is flowing past a point in a given circuit per second. And then we think about resistance, capital R, as how much the charge flow is impeded. And the unit for resistance is ohms, this little guy. So imagine like you have a bottle of Coca-Cola, then you have like an open glass, and you pour them both out at the same time. Which one is going to empty first? So we would say that the bottle has higher resistance to the flow of Coca-Cola. So a circuit with more resistance impedes the flow of voltage more. Okay, let's actually look at a quick example. So we're going to look at a real circuit here. And so let's say that we have this battery, and then this smaller end here is going to be our negative terminal. And then the larger end is going to be our positive terminal. So if we give these electrons a path, right, they will actually travel all the way around to the positive terminal. So make sure you just know that if you see a circuit that's open, that those electrons won't actually transfer. Only a closed circuit will allow for the transfer of electrons from the negative terminal to the positive terminal. So, and then this the little jagged part there, that's how in these drawings we symbolize resistance. So let's say that our voltage is 24 volts. Our voltage is 24 volts. So that means that we have 24 joules of potential energy per coulomb, right? And let's say that our resistance is 6 ohms. Okay, so I want to know what is my current? What is the current of my circuit? So I'm going to actually use this second form of Ohm's law, stating that I equals V over R. I can plug in my voltage, 24 volts, over my resistance, which is 6 ohms, and I'm going to get 4 amperes. So amps, that's going to be our unit for current, and we use this capital A to symbolize amps. Okay, so that's it for AP Physics Online School Day 3. I hope you're all healthy and safe and happy and finding ways to entertain yourself. I clearly am getting very bored, and I miss you all dearly. So let me know if you have any feedback on the assignments or the videos. And then this is a new unit, so if you're interested in some extra resources, just let me know, and I can send you some things to look at. Okay. Please come on office hours so that we can work on the classwork together.